All right. Good afternoon, everyone. Hi, my name's Emily Weber. I'm a machine learning specialist at Amazon Web Services, and I have with me Mani Kanuja.
Hi, everyone. I'm Mani Kanuja, Senior AML Specialist Solution Architect at AWS. And for me, it's still morning.
So we are so excited to chat with you today about generative AI on Amazon SageMaker. So there have been a lot of really exciting announcements in the recent period. And today, we'd like to share a lot with you in this space. Obviously, generative AI is a really exciting time. Really exciting inflection point for the industry, for customers, and we're excited to chat about that with you here today. So let's get started.
Yes, let's get started with how you will actually use generative AI, because everyone is just talking about it and no one is really, and we want to use it, but how can we use it in a meaningful way? Like, what are some of the use cases that will come with generative AI, right? So this slide actually gives you a summary of what all can be done, like to generate. And also, let's take a step back. When we are talking about generative AI, I think, Emily, it would be a good idea to just share what is generative AI, right?
Yes.
So
yeah, exactly. So you've heard of foundation models, you've heard of large language models, you've heard of vision models. A foundation model, in a nutshell, is a way to take vast amounts of data, combine that with neural networks in some capacity, run your forward and your backward paths, and then create this model that can be used in many downstream cases, many downstream examples, as you see here. This is an exciting time now because the performance of foundation models is meeting and in many cases exceeding human level performance. So in today's world, we're seeing foundation models that are exceptional, whereas 2 years ago, foundation models were not hitting human level performance.
yes, and also, like, if you look at the term foundation model, it's literally a foundation for doing all of these above use cases that you can see. And this is just a high level category. There is so much that can be done and so many use cases coming out of it. And when we say we are using the word generative AI, we are literally generating stuff, generating artifacts, right? Whether it's text, whether it's code, image, from text, image to image. So there is a lot going on there. And when we say text generation, what do we really mean by that, right? Like generating a blog maybe, or writing a book summary. And this reminds me actually of a very cool use case. So I recently published my book on high performance computing on AWS, applied machine learning and high performance computing on AWS. And one of the reviewers, they actually built a generative AI assistant to give a book review. So he didn't.
Love it.
Yeah, that was so cool. So the AI assistant was able to summarize the entire book, and he was like very kind of interacting with it. What does the book covers? What about the authors and everything? So very cool use cases coming out of it when it comes to text, or generating audio from the text, or generating images from the text. And Emily, would you like to talk about the image generation? I know you have been doing a lot of work around that.
Yeah, no, image generation is fascinating. I mean, actually, we can take a look at sort of one of our customers in this space, which is Stability and Stable Diffusion. So in image generation in particular, essentially we're taking billions of image text pairs, right? The Lion data set, billions of image text pairs that can be combined again into a model that then generates new images. So you provide new text and then it generates images from the text. Again, Stability is a customer of SageMaker. They were running distributed training on SageMaker. They increased their training efficiency by 58% using our distributed training libraries and are building amazing models on AWS. So we're absolutely thrilled to have them. And as you can see, so in the vision space on the left-hand side, you see an interior that was generated by the model, right? So you can provide a large prompt that we'll chat more about how to do that later on today. But you provide a prompt to the model, and then you sort of hack the prompt. You perform prompt engineering to get the prompts as good as you can. And then you get this beautiful response that wasn't in the training data set, right? The model is learning different aspects of the image and learning the relationship between the image and the language, and then is generating sort of new combinations of these that weren't in the original data set. And then on the right-hand side, you see this sort of image to image transformation, whether that's just purely improving the quality of the images by that upscaling process on the lower right-hand side, or on the upper right-hand side, you see this sort of like image to image masking process where you can provide an image, apply a mask to that, and then use that to create a net new image. And so there's a lot of, again, creativity in the space.
Yes, absolutely. Absolutely. And, Emily, you mentioned about prompt engineering, right? And I know that we are going to show a cool demo, but how about we touch base a little bit about what is prompt engineering before we move forward with that? Like in a nutshell, how would you define prompt engineering to our,
Sure.
we are very new to this?
Yeah, so prompt engineering in a nutshell is the process of writing a good prompt for a generative AI model. So that can be a text string, that's primarily a text string in some capacity. And how do you do good prompt engineering? You look online, you find good samples of this, you find good examples where it's been done previously. There are many different types of prompt engineering, where you can have a number of examples actually that you send to the model, which is called few-shot learning. Again, where the model isn't actually updating any of the parameters, so you're not strictly learning, but at the same time, it's a type of learning, so we call it few-shot learning, but you're providing a number of samples, you get a better response. There's also, again, zero-shot learning, which is what most sort of users prefer, which is where you provide a basic text to the model, a basic prompt, and then you get back a response from that prompt. And so prompt engineering means a lot of trial and error. It means finding good prompts, learning about the model, learning about how to prompt the model appropriately, adding new lines, adding the right tokens, the right strings, to get good responses from this.
Yes, and what you see on the screen is, and while Emily was explaining it, the reason I put it out is just to show you some examples on what can be done, right? So based on what task you are looking at, like you might want to just summarize a particular dialogue. And as Emily mentioned, like we can provide examples also. Like on the left, what you see is Cohere's model, which is basically a proprietary model by Cohere. And they're using their summarization API to summarize a dialogue between a customer and an AI bot. And you provide certain examples, and then you ask a question. In this example, like customer is saying, I want a book to product a demo, and they are getting a proper response based on the examples that were provided earlier, right? So that's what we call as few shot, which Emily just explained. Then another example that we have is the AI21 lab. And also AI21 is our customer, and they train their model using SageMaker, right, Emily? You can correct me. Okay.
Yes.
So we do have like very tight partnership with AI21, Cohere, and also in the proprietary model space. And we have very tight partnership with Hugging Face that you might already be aware of when it comes to the publicly available models.
And Mani, if someone wants to use a proprietary model on AWS, how would they go about doing that?
Yeah, so what they can do, maybe we can take that up in the demo part. How about that?
Sounds good. Where we will look at our foundation model hub. So SageMaker provides a foundation model hub that includes both proprietary and open source models. And you can easily invoke those models. You can interact with those models using, again, your AWS settings. And so we'll look at that in just a little bit.
Yes. And another customer example is this, which is, again, this is image to image, where this really shows you how generative AI is actually transforming AI. There are a lot of image patterns that you see on the left. This is by LG. Again, they trained their model on using on AWS using SageMaker, and were able to train it faster by 59%. The cool thing that I really like about talking about this particular use case is they generated this print using the images that you can see on this left side. And this was used to design a line of clothing. They call this as their AI designer, Tilda. And not just that, this was actually showed up in the New York Fashion Week in February 2022. So Tilda can actually design clothes, and not just that, there's a whole line for it that people can use it, and that was shown over there. So it's not just how we can use and do the cool stuff, but it's literally how we can use it in production with meaningful value add, right?
Yes. And so in this use case, it's wild. So a fashion designer sort of working without an AI model, but just independently, it takes them about 9 months to go from idea to having the clothing in their hands. Using this model, the fashion designer was able to do this start to finish in 1 month. So the time to produce is just so much smaller, right? We in the content creation space, creatives, artists, humans out there who love using ideas, we can just go so much faster using these models and using the content and the knowledge within those models that then enhance our activities in our daily lives. So really exciting.
Yeah, and that too in a sustainable way. I think they created around 100 something designs, and then only 13 of them were selected, and all of them went into the virtual landfill. Right? It's a sustainable way to do that.
It's a very sustainable way to do that.
Yeah. So let's talk about like when these customers are coming up, and when, let's say, somebody who's starting new and they want to come up and say, you know what, I want to use generative AI. So what would be the path, and how would you recommend, Emily, for them to start using generative AI? Or should they start with something what LG has done, or Stability AI did, like train their own model, or maybe use some of those models? So how would you recommend that they start when they are starting their journey with generative AI?
Yeah, absolutely. So the journey of generative AI has many different twists and turns. I'll say the most common pattern is sort of what we have described here. So most customers, most individuals, most companies will start, again, on that left-hand side doing prompt engineering with existing models. So this means you'll look online, you'll look in the SageMaker hub, you'll look in a variety of places and find an existing model and then just test that, whether that's a text model or it's a text-to-image model, maybe it's a music model, maybe it's a video model. You'll, again, use this model, invoke it with prompting, and then, test it on a pre-existing model. You don't need to customize the backend model, but you do want to customize the prompt. So you will need to modify the prompt according to the model. And it's absolutely possible to find a case where this sort of solves your business problem end to end. Summarization is a great example of this. Entity extraction is a great example of this. classification and stylizing are sort of some set of use cases that can be well solved by just prompt existing on existing models. And then once you've sort of exhausted that first phase, but you still, have custom data sets that you want to play with, most customers will then move into a second stage, which is fine tuning. And so this second stage can include taking your custom data sets, modifying the models with those custom data sets. In this cases, you can actually be updating the model parameters using, again, your training data that is specific to that domain. I'll say there are many different types of fine-tuning, from parameter efficient fine-tuning to instruction fine-tuning to reinforcement learning with human feedback, even techniques that don't include updating the model, but they're actually about generation. I'm sorry, about retrieval. So retrieval augmented generation is another way to basically use data that you already have and sort of retrieve that quickly and then stylize the response. And so definitely we see customers sort of fine-tuning in this space. However, there are some of you out there who are actually in it for that third column, which is pre-training. So if you have multiple terabytes of data and the will and the guts to create your own foundation models, you can do this, and we're very happy to help you doing this. And so that is going to include large-scale GPU optimization if you're working with hundreds to thousands of GPUs, hundreds to terabytes of data sets. And the net on pre-training is you want to create your own foundation model. So if you want to create a net new foundation model for hospitality or for financial services or for, sort of your industry, absolutely, we have customers who will take all of their data sets, put their data sets into this massive new foundation model for themselves, and then use it across, tens to hundreds of use cases just within their own company. So absolutely, we have customers who do this. And if you're interested in pre-training, you can check out my book. It's coming out in April. It's actually about pre-training, vision and language models with an end-to-end guide to foundation models on AWS. So that's another place to learn about that. But enough talking. Let's check this out. What do you think?
Yes, absolutely. Demo time. I love the demo part. And yeah, let's start with here. So we are on SageMaker console, and I hope you all know how to get here. So we'll not get into those details. But okay, let's just explain that. So you log into AWS console, type SageMaker, and then you'll be here, literally. So you just have to click on SageMaker and you'll be here. And then on the left side, what you see is this new thing called foundation models. And remember, what we are going to do in the demo is we are starting with our journey, the prompt engineering, fine-tuning, and for pre-training, please buy Emily's book. I've already pre-ordered.
You're too kind.
Okay. So let's click on the foundation models. And what this basically is showing is some of the proprietary models, like AI21 models. I think now we have 6 of them, or maybe 7 of them, 6 of them. And then we have a model from Cohere. We also have a model from Lighton, which is, I think, in French.
Yeah.
And then we also have publicly available models from Hugging Face. Now, you see all these models and you would wonder, this is good, but without trying it out, you have no idea of how you can do that. Or maybe, yes, you will have an idea. So there are certain benchmarks that we want you to take into account. So one common thing that, while you are starting your journey that will come to your mind is, how do I start? My use case might be, let's summarizing, or maybe, generating some text, or maybe images, right? We also have Stable Diffusion. So how do you select which model to use? So for that, you can actually use, you can go to this, holistic evaluation of language models, Helm benchmarks. Just a quick update that this has nothing to do with AWS. This is by Stanford Independent Model Evaluation. You can look at the results. That will give you some idea based on the scenarios on which model to pick. So this is some idea, but that might not be the best one for your use case. So, but we'll give you an idea, and then you come back to SageMaker model, hub over here, and then try it out, right, Emily?
And one quick comment. So Helm again stands for Holistic Evaluation of Language Models. Great team over at Stanford. Essentially, that is one way to poke at foundation models and see, sort of which one is at the top of the leaderboard at a given point in time for a specific task that you're trying to do. But then again, once you've sort of taken a look, definitely the best thing to do is to just open up the playground and then start to test out the models directly.
Yes. So let's try with the, what do you say? Let's try with the image ones. Those were the really cool. I mean, everything is very cool in generative AI. But let's start with the image one, and then we'll go to the text one. What do you think, Emily?
Sounds good.
Okay, let's try this out. And I'm going to use one of the prompt that is very near and dear to me. And how did I got hold of that prompt? Literally by, as Emily mentioned, like searching on internet. But yeah, I was doing it for the demo, but it does highlight some of the really cool stuff when it comes to generating images. So let me just click on that. So one thing to note about here is that the time that it takes to generate the image is not accurate representation, because this is something that we have it for you to try on for free. So it's available to you at no cost, so that you can make a good informed decision. And the prompt that you add, right, the more detailed your prompt is, the better it is. And not just that, you can even talk about in the prompt how you want the lighting, which quality you want, stuff like that, like how the picture should look at. So all of these aspects you can add to it. You can even add a negative prompt, which is optional. And also you can select the width, the number of inference step, guidance scale. And you might wonder, how do I know what all of these mean? And there are so many models, I cannot just remember everything. Then click on the info, and then you will get to know what all these mean. So for example, number of inference steps, literally it talks about the denoising. So when you increase it, it gives you a better output.
It's not that it's necessarily better. So okay. it will take more steps in the denoising process. And so there's a natural balance that you want to find in the overall complexity for how you're invoking the model. And so basically for denoising steps, like if you want the model to work a lot harder, basically to try to produce something, which you might do if you have a very short prompt. Like if your prompt is pretty minimal, and you want the model to kind of go crazy and give you something awesome, then you might increase number of inference steps. Here we already have a pretty complex prompt. And so having number of inference steps be a little bit lower is reasonable. And then similar with the guidance scale, where guidance scale refers to sort of how much we want the model to be creative. So for each inference step, like how creative should the model be, basically. It's again similar with the prompt. So like when the prompt is very complex and you want the model to like just do what the prompt is saying, then guidance scale be lower. But if you're okay with the model like taking some creative liberties, then set guidance scale to something higher.
Yeah, that's a very, very detailed description, Emily. Thank you for that.
Anytime.
Yeah, and you can also look at this, but Emily already explained it.
Seed is another one that's kind of fun to play with. because setting the seed is kind of like changing the overall like style of the image. So if you want it to like pick a completely new or a completely different mode, then you can change out the seed and it'll give you like a similar response to the prompt, but just in a completely different way of thinking about it. So yeah, there you go. Still a beautiful, striking prompt that follows from or beautiful response that logically follows from the prompt. But again, the mode of that or the style of that is completely different.
Yeah, absolutely. And if you like the image, you can just click on the download. Yeah, but remember, this is for demo purposes to understand how the model is responding. And if you feel that, this relates to my use case and I want to use the model, now what should be my next step, right? So once you're done with prompting and we have given you some example of how you can do that, how about using this model, right? And I'll come back to the text part as well, but in a different way. Because another thing that you would wonder that this is good, but I want to deploy the model in my account. And you can deploy, as Emily mentioned, even the proprietary models. There is a different process behind the scene when you are deploying the proprietary models. And Emily, we should talk about how you can deploy the proprietary models, because with the publicly available model, it's very straightforward that you train the model, you deploy the model in your own account, your data is in account, the model is in your own account. But with the proprietary model, things will be different, right?
Yeah, definitely. So the proprietary models are different because they're actually running in an escrow account. So there's actually a clean room sort of AWS account that is hosting the proprietary models. And this is so that the model providers can hold on to their weights and hold on to their IP while still letting you, the customer, interact with those models. And so it's nice because then you, as the customer, can send confidential data and PII data to that model without sending it to the model provider. And so that's where this escrow concept comes into play and is really useful.
Yeah, so it's a win-win for both, right? As a customer, my data is not shared with the provider. And as a provider, if I'm providing the model weights and everything is not shared with the customer, right? Everything stays with AWS, right?
Exactly.
And how would you do that? You first have to subscribe, right? So right now, this is in gated preview, so we don't have the cost associated showing over here. But once this is GA, you will see the cost associated over here, and you have to subscribe it before you can use it. But right now, it's in the preview, so you can subscribe it at no cost. But things will change, so be careful on that. And once you subscribe it, you can actually use it. So let's go into the studio. Let's assume that we have subscribed to the model, and let's start to play with this. And also, once you have deployed the model, how you can use it and do, again, some prompt engineering on your own data or the confidential data that you might have, right? Or your domain data.
Yep.
Sorry, I think I jumped a little bit. Okay, so we are here in the studio. Yeah, we keep doing so much.
I know.
Many things, right?
Yeah. Yeah.
So once you are in the studio, you can actually look at the quick start solutions, which is basically Jumpstart. So what we showed you outside was the console or the playground experience, and you can actually explore. So there are many more models that you can use.
Wow, 42. That's awesome.
Exactly. And all of them might not have a playground, but all of them have a very useful value. Yeah, because, for example, like when we are doing Flan T5XXL, this particular model is trained on chain of thought reasoning data. So if there is a use case that you want to do COT, which is chain of thought reasoning, you can actually try Flan T5XXL model with zero shot COT, right? And also, if you want to give few short examples, other models might also perform better. So it's always a good idea to have multiple options to select from. And getting back to, let's say that we have subscribed to the model, and once you do that, you will actually get the GitHub that you can use in the proprietary model. You will get the code that you can deploy the model. And I have already actually deployed one Cohere model in my account, but I didn't get a chance to play with it that much. But never mind, let's do it. Let's play with some other models that I've already have in my account. But then another thing is when you click, so for example, when I'm doing click on the view model, and I do see that I can open a notebook, or I can deploy the model directly from the UI, or train the model once it's available for fine tuning. Right now it's not available, but things keep changing a lot. And then you can go open notebook and deploy this model in your account. And once you have deployed the model, there are multiple ways to do prompt engineering or test out the model. One is that you can use the notebook experience, which is good. Or we also have a small utility that you can use within the studio to play with the models once you have deployed them in your account. In that case, the model is deployed in your account, the data is in your account, and at least in case of the publicly available models, and even in the proprietary models, as we explained, the escrow account concept, you're still secure, right? Very secure. Your data is secure and everything. So let's assume that we have run through this notebook, we have deployed a pre-trained model, and now we want to use it with the small utility that we have. And let me switch a little bit of the context. So we have this utility that we'll share the link with, and you can start using also. And in order to run this utility, all you have to do is go to this file, install Streamlit, and then run this in your terminal. So you are in SageMaker Studio again, you go File, New, Terminal, and once you click on that, I have this over here, and I've already executed this command. You will see that the app is running, and you will see the port number. So what you will do is you will take this URL, which is again the studio URL, up until default, and add /proxy/port number like this, proxy, and then the port number, and hit enter.
And then look at this beautiful thing. And so here you can run this amazing playground from Studio. So right inside of Studio, you can use this awesome playground that Mani built, Mani and team built to select any of those endpoints, right? So on the left-hand side, we get this awesome drop-down. You can see all of the endpoints that you want to run. And then here you can, invoke those models using this one single playground. Yeah, tell us all about it. It's great.
Yeah. And also, like, once you have that endpoint in your account, you would have to really add it to show it on the UI. So you just click on the add new model, provide the endpoint name over here, and then the model name. So whatever model name you provide will actually show on the drop down. So let's try with some data, right? Which one do you want? Let's say there was this Cohere model. Let's assume that for simplicity. And let's say this is my endpoint, right? And you can add inference parameters, or if you already have a JSON template, you can literally browse and add it, and then apply, and you will see that the model is added. So whatever tokens parameters you provide, this will automatically get populated based on that.
Love it. So good.
We'll do this on this because this endpoint doesn't exist. I just made it up.
Oh, got it. Okay.
Yeah. So let's do the thing on the Flan T5 because this is actually deployed in my account. And let's play with it. So there are a lot of prompts that you can use, right? Whether you want to summarize it, whether you want to do few shot. One of the things that I really enjoy, or maybe entity extraction, right? As simple as entity extraction, that there is this prompt and I want to extract the entities out of it. How will I go about this? So let's minimize this and focus on the prompt. So for example, you have this prompt and you want to extract all the entities out of it. You can just run this, and you can also, make it small like this. So now we gave some context to the model and we were able to extract the entities like Pete in New York City because the model is already trained on it. And also, Emily, do we want to do the COT example as well, like the chain of thought?
Yeah, let's check it out.
Okay. I'll start with the zero shot chain of thought, and I really like this one. Can Jeffrey did have a conversation with George Washington? I can ask this question directly, or I can give your reasoning before you answer that question.
Yeah, so that's what chain of thought prompting is all about, is like where we ask the model to explain its reasoning, so that we can see why it sort of arrived at a given conclusion.
Yes. And look at that. They were centuries apart. There's no way they can have a conversation, right?
Correct. Only in a GPT world can they interact with each other.
Absolutely. And not just that, like we can also do some mathematical stuff, right?
Yeah, let's check this out. Okay, Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3. How many tennis balls does he have now? All right, so question, answer, and then a question, and then we're asking for an answer. So this is like a few shot prompting scenario.
Absolutely. So let's do this. I'm more interested in the explanation, right? Because just the calculation is nice. Wow.
Spends 10 times 0.5 hours a day taking care of dogs.
And the rest is business.
Well, yeah, clearly.
Right. So it does give a right answer, and it also does it in a way that was explained earlier by providing example, right?
Wait, is it the right answer actually? Because because he doesn't spend 35 hours a day, right? So in the question, wait, takes care of 10 dogs.
Yeah, per week.
Oh, I missed that. Okay.
Yeah. No, I calculated it before showing.
Yeah, sure. Oh my gosh, that is a lot of dog walking. Goodness gracious.
Along with the business, right?
I mean, how does he have time for business? He's spending 35 hours a week walking his dog. Crazy. Maybe. Okay, yeah, there we go. 10 times 0.5. Perfect. Very nice.
Yeah, so there is a lot, right, within prompt engineering that you can do, like few shot, zero shot, mathematical reasoning, yes. And also what I did was, this is a very, not a funny example, but I really like this because this is a very serious example that I'm going to show you next. So I actually went to the website. I was just looking at, because inflation is going on, and I was looking at, okay, how do I see my personal inflation? And I got this from, I think, Fidelity website, that they were explaining about the impact of inflation. And then they had this very cool example. So I was like, let me try this. And then, yeah, and then I added my stuff.
Okay.
And I wanted to know what will be my personal inflation.
Okay, let's see.
Let's see. Now this makes me a little bit nervous because I'm really talking about my stuff, and I'm also asking for a reason. Okay. So it's higher. That's what I'm saying. It makes me nervous. The reason, and it's right answer, to be honest.
Yeah, I mean, it's probably because of Los Angeles.
And renting.
Yes. Yes.
Yeah. If I own the apartment like Ted is doing in New York, which is expensive, but he owns his apartment. And
Right.
if he's spending so much in food, eating food from outside, it doesn't really matter. It's more about that his money is going into the equity. A lot of financial terms, right? But I
Yeah.
like this.
Interesting.
Yeah. So now I'm thinking of buying a house.
Oh man, those rates are still going to get you though.
Yes. Invest in equity. Use the rent as a mortgage payment.
Yeah. Oh man. Yep.
Yeah. So yeah, so this is how you can do prompt engineering with some very serious data like we did right now. So yeah, and this will be available to you so you can try it out. And once you're happy with that, you can actually go back to Studio and fine tune the model also, right?
Yes. How does this work?
Yes. And uh, Emily, just checking on the time. I think we have time to go through the fine tuning, right?
Yeah, let's run it and then we can talk about it.
Okay. So there are two options. If you are using quick start solutions like Jumpstart, let me just click on it again. There are certain models that can be fine tuned, like Stable Diffusion. So you have the script, you have everything that you need to fine tune this model. So you click on it, you go to the notebook experience, or maybe fine tune it from the UI, like here, train the model, provide your data source, or just open the notebook and you can actually fine tune the model. Or we also have very good examples that are prepared for you that you can refer while fine tuning, and you can literally download any publicly available model to fine tune it. So one is the Stable Diffusion. The other example, Emily, that I have is actually from the AWS samples from the repo that you take care of, the SageMaker distributed training workshop example.
Sure, yeah.
So yeah, let's go through that also, right? So we have this open source repo.
Yeah.
A lot of amazing examples over here. I literally learned my data parallel, model parallel from these examples that you can refer. And Emily, anything that you would like to point out in the repo?
Yeah, I mean, let's figure out how to do some Pokemon fine tuning.
Okay, so this is a Stable Diffusion one, right?
No, so it's actually in the first one.
Okay.
Yeah, so it's in data parallel, and then lab 1 Stable Diffusion, that folder.
Okay.
Oh, no, actually, this one is that one's PyTorch Lightning. So let's go back up, and then it's this folder.
Okay. You know what? I think I've cloned this repo. Let me check quickly. Otherwise, we can go from here there. Yeah, I have the repo cloned.
Okay, cool.
So I like the black background.
I do too. It's much easier on the eyes.
Yeah, only if I can open up the folder. I have so much stuff opened up. Like, look at this, the terminals and the notebooks.
Yep.
And that's again a good practice. If you're not using it, please don't be like me. Just close it. Like, go over here and then shut everything down. Like, you really don't need all of that stuff.
Yes,
right?
So, gateways. Yep.
Yeah. So getting back to this. Okay. This is not opening up because of a lot of things that I'm doing. So let's go through this over here. Okay. So in this notebook, and we can just, increase the font so that you can clearly see what we are going to share. So first thing first, right? So when you are doing any kind of fine tuning, what do you need? First, you need to install stuff. That's what we are doing over here, but you need data. So you will first load your data set. If you already have it on S3 or any of the file systems, you can directly plug it in. If not, then you can, load the data set like we are doing for the Pokemon one. And once you have loaded the data set, you can, plot it, see how the data set looks like. And once that is done, then the second part is that you want to launch a distributed training job on SageMaker. So what are the different aspects that we need? We would need a machine on which the job will run. So we will specify, okay, which instance on AWS do we want to, start this. And the second is, okay, on this instance, I need an environment which has, my packages already installed, or if I want to have my own container with own environment, then you can do that. But at AWS, we literally have, as mentioned over here, 70 plus pre-built containers which are tested and optimized for SageMaker. So in this case, we are using the PyTorch. When we use this from SageMaker PyTorch, we are literally using the PyTorch container, which has a lot of packages already installed, so that you don't have to go through it. But if you need to install your own packages, there are 3 ways. One, get your own container. Actually, 2 ways, right? Get your own container. The second one is you can mention the requirements.txt file in the source directory, and it will automatically see that, okay, I have this requirements.txt. Let me install the additional packages on top of this. So there are 2 ways you can, have your additional packages, and then you provide your training script. This is literally a script in Python. All you need to do is parse these hyperparameters using argument parser. And once you have provided that, make sure that you provide this distribution. Emily, would you mind explaining this distribution? I think you can explain it much better than I can do.
My pleasure. Yeah. So what we're trying to do here is train your model, right? And in a small data set, small model world, you can just use one GPU. You use one GPU, you run your job, life is done. Life is easy, the work is over. But as soon as you're trying to use larger data sets, then you want to add more GPUs or add more accelerators to this process in order to speed it up. And so data parallel is a way to do that, where essentially you can, again, add extra accelerators, be those GPUs or Trainium chips, Trainium accelerators, to speed this up. Data parallel will make a copy of your model per accelerator, and then actually split the data. So each copy of the model will see different sets of your data. Each set runs its own forward pass using a different split on that data. And then the backward pass actually communicates across all those copies of the model and synchronizes them. And this works because your normal stochastic gradient descent uses an average anyway. Like it just, in any case, is just averaging the loss for each object in your batch, in your mini batch. And so when you distribute it, we're still taking the average. We're just taking the average across all of the accelerators, not just the average across just one. So I'm saying this because it's mathematically the same between distributed or single. But so SageMaker DDP and PyTorch DDP are different ways that you can enable distributed software to run in your training cluster on SageMaker. So different ways of doing that.
And do you have any recommendation, like when to use SageMaker DDP or when to use PyTorch DDP, or just like a choice?
Yeah, so it's definitely a choice. In this case, we're using PyTorch DDP because we're using those G5 instances. We're using the G5s because those are a tiny fraction of the cost of the P4 series and the P3s. So G5s are much less expensive. They're great for developing and testing. So when you're, learning how to do distributed training, when you're learning how to just scale up your jobs to multiple instances, multiple GPUs, then the G series is appropriate for this. And then you'll want to use PyTorch DDP for that G series. However, when you want to scale this up and when you want to, train your own foundation model, or fine-tune larger data sets, then using the P4 series, P4D, P4DE, those are both good options. They're much more performant GPUs. Actually, they're much stronger accelerators. The Trainium accelerator is a great option as well. And those all work nicely with the SageMaker distributed data parallel library, which is a good thing because that is going to run 20 to 40% faster than open source on AWS. So that's a big reason why we like SMDDP.
Okay, awesome. And you did you also touch? You mentioned Trainium, right?
Yes, I absolutely mentioned Trainium.
Oh, okay. And also, I've heard that it's a little expensive than the one sometimes on the cost that is shown. But then, when we look at the cost, right? How do we explain that? Okay, this will be better in performance and also in cost. Like, I just ask the straightforward question: what is train to cost? Like, right? Cost to train.
Yes, yeah. So Trainium is much less expensive than the comparable P4 series, for example. So Trainium is way less expensive than its sort of peer accelerators, the P instances, the P series, and it's actually a lot faster. Trainium, it's fun to work with for training models. It actually uses a compilation stack. So it uses well, it doesn't use, but when you are using PyTorch XLA compilation, then it's much easier to integrate your scripts onto Trainium. So first you need to sort of add PyTorch XLA compilation to your scripts, and then you can run on Trainium. And then you'll be much faster. So here we're seeing almost a 3x increase, 2.6x, a lot less energy consumed, much more energy efficient, and then a 75% lower cost. So a much lower cost for the same compute, right? So basically, you think about the cost per TFLOP, cost per operation in your model. And so Trainium is just much less expensive. So obviously the higher speed is amazing. But the huge reason we care about this again is just the very significant cost savings. So absolutely Trainium is a great option for generative AI, in fine-tuning models, in pre-training models. And then when you're hosting models, Inferentia is another great option as well. More custom accelerators on AWS, where you can easily, again, using compilation, be that through PyTorch XLA or just the Neuron SDK, you can compile your models and then deploy them onto Inferentia, for, again, a massive cost savings, a speed boost, and an energy reduction. So on average, take a look at Trainium, take a look at Inferentia on AWS, on SageMaker, and then, reap the benefits.
Yeah. And I know that we covered a lot. We talked about prompt engineering, we talked about fine tuning. And there is also on the deployment side, we also have SageMaker hosting features that you can use to deploy the models in a very effective way. And what Emily mentioned with Inferentia, you are compiling the model. That's one of the way to optimize the model before you are actually deploying it, right? And there are so many other ways to do that. So what I would recommend is to watch this space because there is a lot, and also with deployment, we also have large model inference container. And let me actually quickly show you that slide, because when you are training the models, the next step is to deploy them, right? And when they are large, in training, we understand, we can do data parallel, we can do model parallel, and divide the model. But what if my model, once my model is trained and now it's time to deploy that model, and if that model doesn't fit into the memory, how do I deploy? Like,
which it doesn't. Like if you're trying to deploy a 100 billion parameter model, obviously that thing is not going to deploy in a single GPU.
yes, exactly. So that's where this large model inference container comes into play, which can parallelize the model, meaning shard the model across multiple GPUs to fit the model into the instance and achieve low latency as well, right? So similar to what we have. Yeah, go ahead, Emily.
Yeah, just a question. So on the large model inference container, I'm assuming I like point to a distributed script. So like I bring a distributed backend, excuse me, for my large language model, and then sort of this stack easily scales that across the accelerators. Am I right?
Yes, it does. And you know what? We also have the large model inference container also has some pre-built handlers, or if you want to use them, or you can, create your own inference script as well. So it does a lot of work behind the scenes.
Nice. And then I can wrap this in a pipeline, right? And I can operationalize this whole thing.
Yes, and you know how this whole thing will look like, and there is a lot that goes on behind the scene. A lot of packages behind the scene like Accelerate, whether you want to use deep speed. This is powered by DJL serving, and a lot of that goes into this full container, that we have. And also to your point, Emily, if we look at how this whole hosting and optimization pipeline with LMI, which is large model inference, looks like. First thing is, once you have trained the model, you can look for the optimization options. Optimizations can include compilation, which we touched base with Neuron SDK, and also quantization, like quantizing the model to, let's say, floating point 16, and now even integer 8 is available. And we can share some of the examples that we have for the hosting with you, that you can start from there. So that can reduce the memory footprint and the requirement of this large instance. But yeah, if you are doing like quantization to integer 8, there will be some accuracy, might be some accuracy loss, but it really depends on your use case. And definitely giving it a try, because then you can use substantially lower GPU to deploy that model.
So Mani, I think in summary, and we're probably coming up on time here. So we've looked at hosting, we've looked at training, we've looked at studio, we've looked at prompt engineering, we talked about pipelines. How do people get started? Like what's the next thing they should do to go act on everything that they just learned about here?
Okay. So the way that you can get started, and again, Emily, I think we touched base a little bit. There's so many ways to do that. But what I would recommend is go to the SageMaker Studio, like the Jumpstart option that we showed you. Try out the model, but before that, define your use case, like super important. Make sure that you have a proper use case in place that is generating some business value to you, and then look at the Helm benchmarks. For now, we have those which are based on the few shot. Pick up few models that you feel might be a good idea to do that, whether they are publicly available, whether they are proprietary models. Come to SageMaker, Jumpstart over here. Try out these models. Trying out the models doesn't cost you, so we highly encourage that you do that. You can even try out the proprietary models with the tryout button. Play with them, and once you have finalized one or two models, go to the SageMaker Studio domain like we did. Fine-tune the models if needed. A lot of stuff going on over here. So fine-tune the models that you need if you need it. And as Emily mentioned, there's so many fine-tuning options as well. Explore what is needed for your particular use case. Then you can deploy the model, and you can use this utility that we'll be sharing the link for, and do some prompt engineering, test it out, rinse and repeat. So, and also use those optimizations that we talked about, like for training, the distributed training libraries that we showed you. For deployment, like if there's a large model, use large model inference container, optimize your model before deployment. All of that will help you in saving cost, in having better performance. And anything you want to add?
Yeah, really, really quickly, you can also label all of your data. So definitely you can stand up a connection to SageMaker Ground Truth to evaluate the prompts, to evaluate the model responses, to take feedback from your teams and incorporate those into the model response. We'll be sending out a link to a way to stand up reinforcement learning with human feedback using SageMaker training and SageMaker labeling. You can add instruction fine-tuning to that. You can add chain of thought tuning. You can add sort of any type of fine-tuning, parameter efficient fine-tuning technique that you want. We'll have that in there, and then you'll be ready to go.
Yes, absolutely. And that was a wrap.
On that note, thanks, folks. It's been a pleasure, and we'll catch you on some future episode of SageMaker Fridays. So thanks.
Thank you.